So today we're going to learn how to draw curved mirror diagrams. In order to do this, you basically want to draw three very predictable lines that hit your curved mirror, always the same way, and lets us predict the image because all three lines pass through the same point. They predict where your image is going to be, and then you can describe its characteristics. To do this, you really have to learn the three rules. And there's three rules, they're always the same, and they're just slightly different for your concave and your convex. So our first rule is this: a beam of light aimed straight at the mirror is going to always go through the focal point. So we'll start by drawing this first one. So you can see there's my beam of light going in, and then I'm going to draw my beam of light bouncing off from that point and going down through the focal point. For a concave mirror, it'll always go down because the focal point is on the inside of the mirror. On the convex, it's going to do the same thing. It's just that it's going to line up with the focal point because it can't actually go into the mirror, right? This is a solid object, and the focal point is on the inside. So what we do is we draw our lines so it would line up. Now, of course, I wouldn't draw this last bit. What it would look like is it would look like this, right? When it bounces off the mirror. So straight in, and then your ruler will go along here so that this line lines up with the focal point and with the spot where it hit the mirror. Rule number one. Rule number two. Rule number two is basically the opposite. The light goes through the focal point first, and then it's going to bounce off, so it goes straight. So when you go to draw this line, the light goes through the focal point, hits the mirror, and in the concave will bounce straight out. In the convex, it's aimed at the focal point. You can see this dotted section. It's just showing that I'm aiming it at the focal point. The light actually would stop right here where it hits the mirror. And where it hits the mirror, it will go straight out. So that's rule number two. A beam of light aimed at the focal point reflects straight off the mirror. Now there is a third line, and the reason we draw three and not just the two will cross, but two crossing could be a coincidence. Three crossing is never a coincidence. So the third one's really straightforward. Light going through the center of curvature will bounce right back along itself. So it's actually just kind of one line, right? Same with my convex. I'm going to aim it at the center of curvature, and it'll bounce back along itself. Where those three lines meet, that will be my image. So what does the real diagram look like? I want to draw all three lines on the same diagram. And I want to draw all three lines in the same diagram so I can locate where is my image. So this is what we do. We draw this red dotted line, which is our principal axis, and on it we have our focal point where all the beams will concentrate, and then the center of curvature, which is always double the distance from the mirror compared to the focal point. It's also the center of the actual circle that would be drawn if you continued that curve. All three lines are always going to be drawn the same way, and we always start them at the top of the object. We want to locate the top of the image because that will show us if the object is upside down or right side up, right? Whether it's inverted or upright. And this will be one of the characteristics we need to describe. All we're going to do is draw all three lines, locate the image where they cross, and we're good to go. So rule number one, starting at the top of the object, I'm going to go straight in like that. That one will go down through the focal point. That's rule number one. There we go. Draw it on your diagram. Rule number two, top of the object, through the focal point, and then straight. You'll see they cross. That's a good sign, right? I'm going to draw my third one, though, because my third one should cross at around the same point. It might not be perfect. Remember, these diagrams have been done on a computer and probably not are perfectly to scale, and you're using a pencil and a ruler, so it's not also perfect. Just do your best. Be patient with yourself. Third one, top of the object, through the center of curvature, and back along itself. So you'll notice, and I totally didn't go back along itself, you'll notice that my three lines cross, right? My three lines cross right here. That is where I'm going to draw in my image. So I'm just going to take a pencil and I'm going to draw in my image. my image, you'll notice this is the top of the image because this is the top of the object. So that means this is where the pointy part is. It's below the principal axis, which shows it's an inverted image. I can now describe, using the SALT characteristics, my image. My image is smaller. You can tell that arrow is smaller than the original. It is inverted. You can tell that's upside down compared to the original. It is closer because it's closer to the mirror than the original. And if I had a screen, I'd move my screen back and forth, and this is where it would actually focus. We also know inverted images are always real. That's super important to understand, that inverted images are always real. That also helps you with these diagrams determine whether it's real or virtual. Inverted has to be real. It's on a screen. Rule number, or we'll do an example number 2. Same thing, same 3 rules, right? We're going to just draw them, see where they cross. Top of the object, straight in, down through the focal point. And remember, you can always pause the video, draw your own, and then keep on going. Second rule, top of the object, through the focal point, straight out. Rule number 3. In this case, I'm going to have to go through the center of curvature and then the top of the object. That's okay. It doesn't matter. It still works. And then back through itself. Now, these 3 didn't line up perfectly. That happens sometimes, right? Don't beat yourself up over that. I'm not going to beat myself up on it because it just happens, right? Perfection is what we aim for, but maybe we don't always get. But we can see they should cross in here. We'll still be able to describe the image based on the location. This should be the top of my arrow. Again, it's below the principal axis. So that means I'm going to have an inverted or upside down image. Again, I can describe my characteristics. In this case, it's larger, most definitely. It is inverted because it's upside down, below the principal axis. It is farther because it's much farther from the mirror than the original object. And I would also call this real because, again, if I moved a screen back and forth, this is where the screen would sit, where it would focus, and all inverted images are always real. They'll end up on a screen. We'll try another one. Now, this one's unusual because when I put my rules on, all of a sudden I have a problem. You'll notice my first one goes in straight down through the focal point. No problem. I can't even draw my second one because how do I go through the top of the image and then the focal point? They're sitting on top of each other. We'll draw our third one though, just to check. My third one, center of curvature, through the top of the object, back along itself. What you'll notice you did is you ended up with 2 parallel lines. 2 parallel lines will never cross. This is why there's no image at the focal point. If you put an object at the focal point of a curved mirror, you don't get an image. It's switching over from the real image over to the virtual. You won't get it to focus. Not looking in the mirror, it'll be fuzzy. Trying to put it on a screen, it'll be fuzzy. Doesn't happen because all the light is parallel. So we would say, when we try to describe the image, we just say, no image, because everything is parallel. Obviously, I wouldn't ask you to draw that one on a quiz. That one was a tricky one, but it does show why there's no image at the focal point. Okay, we'll try our last one of these concave ones. In this case, I'm going to go in and then down through the focal point. Rule number 2, through the focal point and the top of the object and out. Now you'll notice these aren't going to cross on this side, but remember we're closer than the focal point the object is, so we should be getting a virtual image based on what we know about the characteristics of the images. Third rule, there we go, center of curvature, back along itself. Now you'll notice these 3 reflected beams don't cross on this side, but they will cross on the other side. So if I trace them back, so I take this one and I trace it back, and I take this one and I trace it back, and I take this one and I trace it back, they cross on this side. Now I don't think I did a wonderful job on this one. This is a little low for sure, you can tell, right? I'm a little low. So they're close to each other. I didn't do a perfect job, but I did okay considering. And I'm going to draw in my image. Again, where they meet is going to be the top of my image. So there is the top of my image right there, right? And now it's above the principal axis. So I will draw it above the principal axis. And now all of a sudden I get an upright image. So now it is larger. It is upright, right? Not upside down or inverted anymore. I would call that closer because it does look closer to the mirror than the original. And finally, it is virtual. And I know that because I had to trace these back to find it. So that means the image is actually inside the mirror. Because remember, you'd be looking from over here and see the image inside the mirror. It's also upright, and all upright images are virtual. Last example. In our last example, we're just going to do a convex. Remember, we're going to follow the rules, so just be slightly different. Top of the object, straight in. Oops, I'm on the dotted one, not the solid. We'll fix that problem. Sorry about that, not very professional. So, oh, come on. So I will go through the top of the object, straight in. Then I want it to go down towards the focal point, but it's actually going to go up, right? We know that. So I'll just get rid of this little bit. When you're doing this with a pencil, you'll only draw this section. You won't draw that lower section. Rule number 2, I'm going to aim at the focal point, right? And then it'll go straight. Of course, same thing. When you draw yours with a pencil, you're not going to draw this one little section down here. So I'll just back that off because you're going to aim at the focal point. When you hit the mirror, you'll go straight out. And then finally, the third one, we're going to aim at the center of curvature and back along itself. Just like the other one though, we will stop when we hit the mirror. So we actually won't draw this bit in here, right? We'll just draw it so it's aiming at the center of curvature. This is going to be virtual. We kind of knew it should be virtual, right? Because we already knew that we were going to end up with a virtual image. I didn't mean to do that. Right, so we'll do our last one. We're going to trace this back, right? We're going to trace back this reflected light straight on back. We're going to trace this reflected light straight on back. And we're going to trace this reflected light straight on back. And you'll see they meet. They meet really nicely this time. You'll see they meet quite nicely right there. That is where I'm going to put the top of my image, draw it in, and then I can describe my image. It is definitely smaller. It's definitely upright. It's definitely closer. And I would call that virtual because you'll see I had to trace back to